Algebra Nation video will cover your workbook page 100, the right side of page 100, and we're going to go ahead and do all of page 101. So here we go.
Check it out, dudes. We're going to do radical monomials. They are radical. But first, what we're going to do is we're going to look at perfect squares. So check this out, man. For perfect squares, I'm going to look at x's, and I'm going to square them. So ready? 1 squared is 1. 2 squared is 2. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, my head's in the way. So let's move it. 5 times 5 is 25. 6 times 6 is 36. 7 and 7, 49. 8 and 8, 8 times 8. I shouldn't say and, I should say times. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. You know what you should do right now? You should pause that video, write this down. So here's the idea. For numbers that are in the chart, you just write the answer. Basically, when you see this little symbol here, this radical dude is called a square root. Basically, when you see these lines together, you're like, I will think of two numbers, and they must be the same. And when I multiply them together, they got to equal what's inside of there. That is what a square root does. Again, I must think of two numbers, if it's a number, and when I multiply them together, they got to equal what's inside of there. So the square root of 49, check it out. Square root of 49, well, 49 would be 7 times 7. So there you go. There's your two 7s under the square root. So in this case, we would say the square root of 49 is just 7. And there's your answer. And I cannot keep up this surfer accent the whole video. So I'm going to go back to the way I normally talk. Fun little fact, I'm from Hawaii. I'll leave it at that. Square root of 49. So the square root of 49 is just 7 because you saw it's 7 times 7. And I got a pair under a square root. So that's why the answer would be 7. A square root asks you to go backwards. The opposite of squaring would be square rooting. The square root of 16 would be 4. Because we know 16 is 4 times 4. And there's your answer. But you and I both know it's not going to just stay with those. If the number is not perfect, because not everything is perfect, see if there's a perfect square that goes into it. Meaning, square root of 50, when I say goes into it, I mean is a factor of it. How can I go ahead and rewrite 50 so it's going to have one of these times a number? 50, you might think of, is 5 times 10. That's not on the chart. I don't see a 5 or a 10 on the square side. 10, though, is 5 times 2. So there you go. I've got a pair. I've got a pair under a square root. If anything, if you thought of 25 times 2, that would have been best, but it's not absolutely needed. You just need to make sure you have two of a kind. So 5 times 5 is 25, and the square root of 25 would be 5 on the outside, and you'd have a square root of 2 left over. So that's how you simplify a radical, specifically a square root. And again, you've done this before where not everything works out perfectly. Fractions are an example where you simplify, but you might still have a fraction overall. Square root of 18, ready? How would I write that out? I'd say 9 times 2. And if you got that, awesome. You know 9 is a perfect square. It's one of the numbers on this list. It's a perfect square, and that's why we wrote these in the first place. So the square root of 9 is 3. Again, this chart will help. The square root of 9 is 3. And you're left with a square root of 2 left over. And that's how you'll simplify a square root when it's not perfect. So ready? You know what's coming. I want you to try these two out. Pause now and try and simplify these square roots. Square root of 27. 27 is 9 times 3. There's a perfect square there, a 9. The square root of 9 is 3 with a 3 left over. So I took out the square root of 9 and I left the 3. 8. 8 is 4 times 2. And I have a perfect square of 4. The square root of 4 is 2, with a square root of 2 left over. At the same time, if you need to write it all out, by all means go ahead. If you had to write out 3 times 3 times 3 to see the pair, then by all means get that pair out. And that pair will be on the outside with 1 left over. If you had to write 4 as 2 times 2 times 2, I have 1 pair with 1 left over. So that's how you're going to simplify the numbers. But then we have the variables. For variables, we want to talk about when it's even and when it's odd. When it's even, remember, what does x squared mean? X squared means x times x. So automatically, I have 1 pair, and that'll give you just an x on the outside. At the same time, though, just ask yourself, how many pairs do you have? Now, I know I only did just one example here, but I want you to try this and see if you get a pattern. See if you find a pattern with these next two, okay? You need to write them all out to see how many pairs you have. Go for it. Otherwise, I hope, in just a second, pause, see what you come up with. Y to the 10th power is y, or y. It's 10 y's. How many pairs is that? 1, 2, 3, 4, 5. It's 5 pairs. You had to use your hands for a second. There was 5 pairs overall. So that would just be y to the 5th. A to the 10th is a. Yeah, I said that correctly. Awesome. How many pairs is that? Again, that's 5 pairs. 1, 2, 3, 4, 5. C to the 6 is 6 C's. C. That's 1, 2, 3. 3 pairs. You guys see a pattern here, though? One way to think about it is you can just cut it in half. Another way is asking yourself, 2 goes into 10 5 times. 2 goes into 10 5 times. 2 goes into 6 3 times. That's how I think about it. Because this is a square root. We're trying to figure out how many pairs we have. How many pairs? So how many pairs do we have? We had 5 pairs of y. We had 5 pairs of a. And we had 3 pairs, or 3 pairs of c. But that's if it's all even. What if it's odd? Y to the 13th is, I can't do that with all my fingers. Y to the 13th is 13 y's. So how many pairs is that? I mean, if you had to, you could write out y 13 times. That is 1 pair, 2 pair, 3 pair, 4 pair, 5 pair, 6 pairs with 1 left over. So that would be y to the 6th with 1 left over. Or again, I would ask myself, 2 goes into 13 6 times with 1 left over in the radical. That's how I would work it out. Again, 2 goes into 13 because we have 13 y's. It's the exponent 6 times with 1 left over. Just like 2 would go into 7. How many times? 3 times with 1 left over. So if it's odd, you're going to notice that you have 1 left. So again, I want you try 2 of these out. Give them a try.
I thought he said take a brain break. So remember, when you get to that hard problem on the EOC, you gotta bust the moves like this. Taking it to the house, baby. He gone.
I'm going to pause again. Simplify. I have, let's see, looks like 5 Ks. So in this case, if I have 5 Ks, how many pairs is that? How many will I have on the outside? That would be 2, or K squared. Remember, I say 2, but it's really K squared with 1 left over. If I have 5, that's 2 pairs with 1 left over. C cubed is 3 Cs. That's 1 pair with 1 left over. So now you've seen numbers, now you've seen variables.